Good morning, everyone. Okay, today we're just going to do a review for any question that you guys are not feeling comfortable with. So would you like to start? Do you have any questions that you want me to talk about?
Can we do integration by parts?
Yeah, that's a question you guys asked about yesterday. Anything else? Okay, so we will do that integration by parts, you say, okay? I will take a very simple, very traditional problem. Suppose you have the following integral of, let us say, 6x plus 2 times ln of x dx. Yeah, why not? Okay, so usually we use integration by part when we have one scenario like ln of x times something, e to the x times something, cosine x times a function of x. And if you have ln of x itself, and if you have tangent inverse, sine inverse, that's where we use the integration by parts. So let us try this one. So this is there is no other way but integration by parts. So how shall we do that? We have to introduce a u. We have to make a choice of u and a choice of dv. What's a good choice of u in this particular problem?
ln of x.
ln of x is my choice of u. And dv is, once you pick the ln of x, as I said usually before, is the leftover, which should be the dv. So the dv would be 6x plus 2 and a dx. Okay. Now we do that, and that's what will give me what? If I put u to be this, so the du is the 1 over x dx, and the v is the antiderivative. The antiderivative of 6x is 6x squared over 2, plus antiderivative of 2 is 2x. Okay, so now we just have to plug in the formula verbatim. So this would give me uv. So this is 3x squared plus 2x ln of x minus the integral of v du. V is 3x squared plus 2x, and the du is the 1 over x dx. Okay. So it's going to be equal to ln minus the following. Now here the best way is actually to divide across by x. So this will give me 3x squared times 1 over x, which give me 3x, plus 2x times 1 over x, which give me the 2 dx. And that's it. At this stage, that's a simple integral in x, and this will give me that much. Minus antiderivative here is 3 half x squared minus plus minus antiderivative of 2 plus c. Okay, so that's a typical. Could you please number 30 from the conic section homework? Okay, I will look at it. Zach, give me a second. Sure. Okay, any other? I will answer Zach question, and then I will pick up any other question you guys can have. Okay, number 30. And this is from the conic problems. So number 30 was 4x squared plus 4x plus y squared equal to 0. And the question is to identify this conic section, circle, ellipse, hyperbola, and then sketch it or find the foci and so on and so forth. So we have to complete the square. The y squared, there is nothing to do with it. So it's remained the way it is. It's already completed. There is no y term, so I don't have any issue. Sorry, here I have to factor out my 4, and this would give me x squared plus x. Okay, and now we complete the square. x squared plus. Now here the coefficient of x is a 1. So to complete the square, I have to take coefficient of x, which is 1 divided by 2, which is a half, square it and add it, and then take it away. Okay. And now this is going to give me 4 times. X squared plus x plus a half squared, that will give me x plus a half to the power 2 minus a half square, it's 1 over 4, plus y squared. Now let me see, what did I add? By doing this, I have to subtract this from both sides. So I have to, sorry, that's equal to 0, that's equal to 0. Okay. All right, so finally I am done. Minus 1 plus y squared equal to 0. Now my constant term move to the other side. Equal to 1. So it's going to be an ellipse. Now we have to write it in the standard form of the ellipse. And the standard form of the ellipse is x minus h squared over a squared. So we have to rewrite it so it will look exactly like the form of an ellipse. And the way to rewrite this is like that. This is multiplied by 4. So I divided by 1 over 4. So I let it look exactly the form we need.
I have a question.
I'm listening. Yes, Chris.
How does a 0 go? How does it go from a 0 to a 1?
You tell me.
Oh, you add the 1 from right there. Sorry about that. I did not see that.
That's fine. All right. So this is now my ellipse. So this is my a squared. And this is basically divided by 1 because there is nothing. So this is my b squared. Okay. So we're done. So this is ellipse. So that's an ellipse. And the center of the ellipse is minus a half 0. So this is my ellipse here. The center is minus a half somewhere in here and is 0. Now the b bigger than a. So here the a is a half and the b is 1. So we're going to have this kind of ellipse. So the b is 1. So we're going to get 1 unit from here. That's the b. So that's going to be the vertex right here. And the a is a half. So we're going to have this kind of a ellipse. Okay, so now the vertices are going to be this point and that point. So this point is a 1 in here. So it's going to be minus a half and 1, minus a half, minus 1. These are the vertices. Now for c squared, we know c squared, that's an ellipse, so it's the largest, minus 1 over 4, which is 3 over 4. So the foci in this case are right here and right here. So c is the square root of 3 over 2. It means the square root of 3, 4. So the foci are minus a half plus the square root of 3 over 2 and minus a half minus the square root of 3 over 2. Okay. Question?
No, I understand that now. Thank you.
Okay, sure. Okay, so if you don't have anything specific, I would take the review myself and just kind of go over what I'm expecting. I mean, not what expecting, what we've learned. A lot of it I already tried to give you through MATLAB, a review for the problem. So I hope you guys are doing it. I know that some are and some, as usual, aren't. So make sure you do them. Okay, so the first part is bunch of areas and volumes. So area between two curves and volume of revolution. So as I move on, you guys tell me which one that you're not comfortable with. And so expect, of course, problems along those lines. And then we have problem about work. I did yesterday the work problem just to get you going. Now there are spring problems. For the spring, things are usually not hard, because for the spring, the work is integral of the force. The force is usually, for the spring, is a certain constant times x. X is the amount of stretching. Amount of stretching, how much we stretch. And the work is the integral of the force from A to B. It means how much you stretch. If you stretch it from 0.2 centimeter to 0.2 feet to 0.5 feet, so that's from 0.2 to 0.5. And a typical spring problem, usually they either give you, sometimes they give you the K in a very direct way, and a lot of times they don't give you the K, but you have to find the K. So that's the spring problem. They are not really basically hard. Arc length, those I usually give you the formula. You just have to apply the formula. So it means you graph a function. This is the graph. This piece here of the graph have a length. And the question is, what's the length? And there is a formula for that. I usually provide you with the formula. It's your job to really find it. The surface area, it means if you take this and you start rotating it, you generate a surface. What's the surface area? Again, that's a formula that we use. So those are really type of formula we've done. Now, this is the work problem. I think that's very much what I did yesterday. So that's a cylindrical aquarium. I can give you a different shape. You know, that's a cylindrical. I can give you a rectangular aquarium. I can give you any shape of aquarium I want. 12.2 is again cone, again work. So the same idea, but here because I have a cone, when we take a layer, if you guys remember the layer, the radius of the layer changes. So your job would be to use similar triangle to find the radius of the layer. So that's really the picture in those problems. Number 13 is again a work problem, and that's a cable. So you have something and you have a cable attached to it. And let us say from here to here, 150 feet. And you wanna pull this layer up, this rope up. And the idea is, like we did for the cylinder, you divide it into little pieces, and we lift every piece by itself. And so if this is my delta Y, and then the work to lift a piece is the weight of the piece times the distance. So let us say this is the height yi, the distance is gonna be the 150 minus the yi, and the weight is, this is a rope, and what I give you is the density, but this time the density is pound per foot, because that's a linear, this is not a volume here. So the weight is gonna be the little delta y times the 2 pound, which is the density times the length, which makes sense. This is pound per foot, and this is foot. The answer is going to be pound, okay? Uh-oh, you guys wrote something I didn't read it. Would you consider changing the MATLAB due date from tonight to Sunday night? I would like to be able to do those review, and I don't think I would be able. Okay, I can. Okay, I agree, I agree. All right, I'll change them. I will do that. Okay, very good. Now, compute each of the following integral. All right, so this is a bunch of integrals. I will go through them very quickly. So I will have the chance to talk a little bit about series. I will pick some of them and you guys answer me quickly. Is that very clear? So we move them quickly. How do we do that? I want a quick answer.
Substitution.
Substitution. W squared plus 1, very clear. How do you do that? Remember you have the sign.
Would that be half angle formula?
Yes, that's a half angle formula because we only have an even power. It means the half angle formula. How we do that?
No, wait, hold on. Never mind.
Partial decomposition.
That's
Yeah.
exactly partial fraction decomposition. But what do we have to make sure of?
Factor denominator.
Right, we have to be able to factor denominator, and we will be able to factor this denominator because the b squared minus 4ac, if you guys remember, is going to be a positive number. You factor it out, and then partial fraction decomposition. Okay, for me, giving you this problem, it means giving you x. I mean, those problems are simple. You should not have any difficulties with that. So you factor it out, and you write it as a over something plus b over something, and this is going to be 12, so it's going to be like 5 and 6, something along those lines. One is 5, so this is going to be 6, and this is going to be that, and then you proceed. Okay, typical partial fraction decomposition. D is staring at you.
Substitution for tangent.
Right, that's a substitution. U equal tangent to t, and then you have to break up the secant form into secant square and secant, and yeah, 2 secant square. One will pick up the derivative of tangent, and one will be expressed in terms of tangent very easily. Number E.
Substituting x with 3 tangent.
Number F.
Substitute for 4x.
4x? Where did you get 4x from? You're not seeing it carefully, maybe.
Am I looking at the wrong problem?
Yeah, it's F.
Okay.
Wouldn't
Oh.
that be you split up the secant? You take one secant out and one tangent out, and you make that the du or the dx.
Do we need to do that? Once I split the secant, it should be clear.
You could substitute for tangent.
You can substitute for tangent. This will be totally swallowed up by the derivative of tangent. This is going to be 1 plus tangent, and this will be the tangent. Okay. That will be easy way. And the way, Chris, you said it also will work. All right, J or G, whatever this is.
Would that be integration by parts?
Right, how many times?
Twice.
Twice, because you have x squared. That's integration by parts twice, absolutely correct. H.
U substitution.
Exactly. U equal x squared du, because we have the derivative of x squared in front of us. And the reason I put those two problems one next to each other is to remind you that's not always by part. This is substitution because that's x squared and that's x. Right? All right. I will pick some. I'm not going to do all of them. I very quickly.
Integration by parts.
By part. J. That's a typical what? Don't be afraid of arctangent. It behaves exactly like the one before it. That's by parts as well. Okay, that's going to be by parts. But we have to be careful here. This one will be the U. This would be your U. And the dV will be the leftover. GDT. Okay, that's again by parts. So U will be arctangent because I don't know what's the antiderivative of arctangent. And the dV would be the T dt. Okay. K, it again, a typical integration by part problem where the U is the ln and the d is always the leftover, which is going to be that 1 over x root x dx, or 1 over x to the power 3 half. Typical scenario. L.
The partial fraction decomposition.
Okay, tell me the decomposition. What's the form of the decomposition?
Would it be a over v plus 5 and then a over
Remember, that's v squared plus 16. That's quadratic that I cannot factor. If it's a quadratic that we cannot factor, what's its contribution to the, how does it contribute? Sorry, I meant 16. What should go here?
would it be bx plus c?
Right, it should be bx or bv plus c. So be very, very careful. That's a quadratic that we cannot factor, so it has to be bv plus c, okay? So that's to remind you the partial fraction decomposition. Now that's a simple substitution. What about this problem? Do you guys remember how we do that?
Wouldn't you find the square for the bottom part and then do, wait, which one are you talking about? Oh yeah, and
Right, this one, first we factor. If we cannot factor, we complete the square. This is something you will not be able to factor it. So you will complete the square of that term, which is gonna give you x. That should be, I think it's a -3 squared. If you complete it, you're gonna add -9 plus 4, okay? So you're gonna complete the square, and then you're gonna put your u to be the x -3, so we can get rid of that. And then everything will be in terms of u. So x should be in terms of u, which is u plus 3 du. And finally, if you guys remember, I'm doing this to remind you, this would be, we split this into that one, which is gonna give me a substitution, and that will give me 3 times 1 over u squared plus 4 du. This is a typical substitution problem that it's easy. This one, I should remind you, probably you forgot this formula, and that's the arctangent. So remember always, integral of 1 over x squared plus a squared dx is 1 over a arctangent x over a plus c. Okay. The rest is actually rather, you should be able to do it. The only one I should remind you, this one, r. Here it's, the denominator is totally factored out for you. So that's a partial fraction decomposition, and the decomposition would be like that. This term is squared, it's linear squared. This is just simple. The contribution of the linear is that. And the nonlinear is t plus 1. Okay, and then you find the a, b, and the c. Okay, all right. So this is a quick review of the integration. As I said, you will not have x equals secant, x equals tangent on your final. You guys, we learned this, we worked with it. So whenever you need it in the future, you can pull it up. Now, improper integrals, it's like integration, but you take a limit at infinity. So review those. Now, sequences and series. First, you should not at all confuse sequences and series. Sequences is a list of number, no more, no less. So it's just a list. Sequences, you add those numbers. So when I tell you sequence, it means I'm not adding. I'm just telling you, you know, this is our list of number. What happened to them when n is very, very large? That's really about it. So for example, if I take the first one, it means I'm looking at the following list, 1 minus 1, because when n changes, 1, I'm not adding, I'm not doing anything. Sorry. And so on and so forth. So does this limit exist? No, because the terms don't get close to any fixed number. They keep -1 and 1. So this one, let us say, diverges. If I take this one, remember these are sequences, not series. So this is, I'm taking ln of n over the square root of n. I'm asking myself, what happened to that when n becomes very large? I'm not adding terms, I'm just listing them. So when n is large, this becomes very large and this becomes very large. And what's happened to the ratio? Now you should know that this is 0, even though you should show all the work, because look, ln goes to infinity very slow. But to be able to do it mathematically, we use the the L'Hopital's rule. So this would be 1 over n, and the derivative here is 1 over 2 root n. And then if we do the math correctly, we're gonna have 2 over square root of n, you guys do it, which is gonna be equal to 0. Okay, so that's a sequence, it means a list of number. Do not confuse that with a series. So review those, of course, you guys will have to review everything. Now the MATLAB does not have series on it, so make sure you review series, test of conversions, Taylor polynomial. Your MATLAB homework do not have those. Okay, so please review them. Find the sum. When I tell you find the sum, it means I have a geometric series. So what you have to do is figure out the ratio, figure out the first term, and use the formula. And if the ratio less than 1, the series converge, otherwise the series diverge. Okay, this one was done in class. And okay, let me look up number 20. Number 20 is for each series, you have to determine whether it converges or not, and which test to use. So we have the integral test, the limit comparison, the ratio test, the divergence test. Those are the most used tests. And each series will have, you know, its test that it's good for. So for example, A test tells you immediately the integral test. It means you look at this integral. And you ask yourself from 2 to infinity. If this integral converges, the series will converge. So that's a typical integral test. Now B. What test do you think is the appropriate test for that? Number we have integral, limit comparison, ratio test. These are the tests that I want you to use the most. Limit comparison, ratio, and we have the regular comparison. Which test do you think will work with that?
Limit comparison.
Limit comparison. And what shall I compare it with?
1 over n to the 4th.
No, 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 no. What shall I compare it with? The numerator, as n is large, it remains itself. The denominator is n to the 4. Okay, now I do the math. This is going to give me what? Altogether, n to which power? 3 and a half. So this is going to give me 1 over n to the power. That's going to give me 3 5/2. You have to compare it to that. Okay, this one will converge. Your original series will converge. So that's a typical limit comparison test. C is a typical limit comparison test as well. So this one you compare with 1 over n. D, again, a limit comparison. What would you compare D with?
One over n.
No.
One
Why
over
I
e,
said no?
because doesn't e to the n go up to infinity way faster?
Right. Which one goes to infinity faster? This or that? This goes to infinity faster. You compare it with the term that goes to infinity faster. You ask yourself, for when n is large, this number is like what? It's like e to the n. It's not like n. If you compare it with n, you don't get the right answer because it doesn't work. Okay. E, what's the typical scenario for E? Now this is becoming easy. E, that's a typical ratio test. Whenever you have factorial, whenever you have 3 to the n, then it's the ratio test. F, factorial ratio test. G, that's an alternating series test. H, you have 2 to the power 2n plus 1. That's again the ratio test. This one, because it involves cosine, you use the regular comparison. In other words, you say that this is less than 1 over n squared. Now, if the largest converge, the smallest will converge, and of the problem. Okay, so that's 43 from the quiz review. I don't know what you're talking about, Eli. What quiz review?
Or not, the it wasn't necessarily a quiz review. It was just the link to it was just the conic sections assignment. So it wasn't necessarily like something that we had to turn in.
Okay, that's all right. So, but let me make sure you guys get this straight. 21, find the Taylor polynomial. This is easy problem. I will give you one like this. You just have to use the formula. So definitely review the formula for Taylor polynomial. It's just a formula. So there are a bunch of problems which are nothing more than formula for Taylor polynomial. And then here you have find the conversion set. Again, none of you had trouble with it on the exam, but review it because I know that you forgot it, as simple as that. So you have to really review them. Now, what's the rest? Find the power series in X or the Maclaurin series. All those usually, again, those aren't hard problems. You start with the ones we know, which I usually will give you, and then you do substitution. So definitely go over that. Those are typical problems I usually ask. So here you start with a simple one. So you start with 1 over 1 plus x, for example, and then you substitute to x for x. Here, for example, you have to factor out the 3, you get 1 that, and then you use 1 over 1 minus x. This one here, you find 1 over 1 plus 4x squared. You find the power series of this function, then you multiply by x cubed. X cosine x squared, again, you find cosine x squared, then you multiply by x, and f of x is, I gave you the hint, you start with ln of 1 plus x, then you multiply by x squared. Okay, and now when I ask you, give me the first 4 terms, you don't use the formula for Taylor polynomial. You just, once you write it, the first 4 terms is what I want. You don't have to use Taylor polynomial. And review the quiz, I think, review quiz number 10. Review quiz number 10 is very relevant to that. Okay, the rest is simple. The rest is what we've been doing over and over. Okay, now I look at Eli question and I will take a few minutes from the quiz. Since you guys are having all the time you need for the quiz, I will answer Eli and then I wish you the best of luck for everything. Eli?
Yeah. Okay.
This is it, right?
Yeah.
So it's number 43. And you need the equation of the hyperbola. The foci are 0 plus or minus 3. And what else I want? The vertices, 0 plus or minus 1, right? Okay, first the equation of a hyperbola. Foci here is 0 plus or minus 3, so that's my 0 in here. So it's plus or minus 3. So the foci on the y-axis and the vertices is here. So this is really what's going on here. If the foci and the foci are right there. Since the foci are on the x-axis, on the y-axis, so it's going to have the form y minus h squared over a squared minus x minus, I mean, you can use k, it doesn't really matter, k squared over b squared equal to 1. Okay, and then what's the center here? The center is the origin. Okay, now what's the A and what's the B? Actually, I wrote it this way for you. Very good. The B is, that's the vertex, so that's a 1 from here, and that's the 1 from here, so the B is equal to 1. Now to find A, I need the C. So C squared is A squared plus B squared. It means that the C is the foci from here to here, so that's a 9. Is A squared is I don't know, B squared is 1. A squared equal to 8. And the equation would be x squared will be y squared over 1 minus x squared over 8 equal to 1. Eli, is it making sense? Eli? Okay. Good luck on your exam. If you have any questions that you guys have trouble with over the weekend, just email me and I will try to answer you. Okay, good luck for next year and for your final.
Could you put that final equation back up? I wasn't quite finished.
I will put it up. This one?
Yes, ma'am. Thank you.
Okay.